Okay, today we're going to have a look at the spinning wheel and how it works. A lot of people take up spinning and they're not very sure on how the whole thing is set up and how the tension works and that kind of thing. This wheel that we're looking at the moment is a modern wheel, but based on an old design. It's called a Saxony wheel, and it's actually what's called a Scotch tension or single drive wheel. Now I'm going to show you the various parts of the wheel and what their function is. First of all, we have the main drive wheel. This is the thing that powers the whole of the spinning wheel to make the yarn twist. We have at the base of the spinning wheel a treadle plate, and this is connected to the main wheel at the back of the wheel by what's called a footman, which is just a vertical rod attached to the main wheel shaft, which goes through here, through the hub. It has a drive band which goes from the main wheel onto this part here, which is called the flyer. The flyer itself is the business end of the spinning wheel, and this is where all of the work is done, and this is the bit that usually fools a lot of people. This is where the tension device is located as well, and because this is what's called a Scotch tension single drive band, it means that the drive band comes off the main wheel and over one of these grooves on the flyer. This particular flyer has got 3 grooves, and these are basically used almost like gears on a bike. So it means that we can change the speed that this flyer turns at by putting the drive band on a larger one for a slower speed, medium for a medium speed, and a smaller one for a faster speed. So if we want to spin very fine yarn, we would tend to put the drive band onto the smaller wall, and that means that for every treadle of the foot plate, this wheel will turn this wall at a given rate. Now the easy way to work out what your ratio is to tie a little piece of yarn onto the flyer on the top arm, which I'm just going to do. There we go. And I've got another marker on one of the spokes of the wheel, of the main wheel here. Now, what I'm actually going to do is to turn this wheel, and for every time this marked bit on the flyer comes to the top, will tell me that that's 1 full revolution of the flyer, and when this comes back up to the top is when I stop. So we're going to start counting. So I've got 1, 2, 3, 4, 5 and a half. So we've got 5.5 turns on this ratio to this 1 turn of this main wheel. So that's a 5.5 to 1. The middle one, I'm going to do the same for. Put the marker up to the top and start again. So I've got 1, 2, 3, 4, 5, 6, 7.5. So that's 7.5 turns on the middle one, so that's 7.5 to 1. I'm going to put it onto the fine one and start the same again. Markers at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's roughly 11 to 1 on the very smallest wall. You can buy flyers for most wheels, or have flyers made that are much smaller, so that you can get down to maybe 24 or 40 to 1. You can also get much bigger ones where you've got what are called jumbo flyers, which have a bigger orifice here for allowing thicker wool to go through, and quite often they might be down to maybe 3 or 4 turns on the smallest wall, so that you can get much less twist for a much thicker yarn. Just going to take the flyer off so you can have a look at it, because I want to show you the bobbin and the spindle. Okay, so this is the flyer, and as you can see, here are the 3 walls. It has a little hole at the back here and a hole at the front. This is where the yarn comes through. So take that off, that's the marker for the flyer. We have a bobbin which fits onto the spindle. The spindle clips into the back of the maiden here, and the front of the flyer slots into this one here. Put the bobbin on with the larger end of the bobbin at the back. Some flyers are very specific in which way you can put the bobbin, and this particular one much prefers with the bobbin at the back end, because once it gets into here it's too big to fit in between the arms properly. So we're going to clip this back on, put the drive band over the wall first, clip it into the hole, and then into the clip at the back. So that's your front tension. You've also got on this what's called a bobbin break or a bobbin tension, and this comes from this knob here, goes under a little hook at the back, over the top of the bobbin, and it clips into the hook on the other side. Right, so now we're going to look at the tension on the bobbin and how that affects the way the yarn is spun. The yarn comes over the top of the flyer arm. I'm just going to thread it up with this hook. There we are, the hook back there. Now the rate that we want this to twist at is determined by the tension on the bobbin. If we put too much tension on the bobbin, it means that the yarn isn't going to have time to twist properly, so that when we come to ply the finished yarns, we end up with it breaking a lot. So in order for us to get the tension correct, the way that I do it is to get the wheel going and hold on to the end of the yarn. If I push the yarn towards the flyer and it doesn't feed on, it means I need a little bit more tension putting on the spring. And I keep adjusting this so that I can pull the yarn off and feed it back on smoothly while I'm treadling. And once we get to actually spinning properly with loose yarn that we want to twist, I can adjust that again a little bit finer to be even less twist or more twist. Now the other tension device obviously is for the main wheel here. This, to be honest, if you use one of these stretchy bands, you very rarely need to change it. If your wheel is kitted out with one of these old-fashioned string type bands, then you may have to adjust it when you come to change from one wheel to the next. This knob on the end here is the thing that alters the tension on here, and it works by pushing the base of the flyer attachment. This is actually called a mother of all, and it makes this slide backwards or forwards on the base. So if I turn it this way, it pushes the flyer towards the main wheel, and if I turn it that way, it screws it back up and away from the wheel, so it puts more tension on it. But as I say, with these stretchy bands, you very rarely need to alter the tension on these wheels at all. That is only needed to be as much tension on there so that it doesn't slip on the main wheel. If you don't have enough tension, and particularly with the string bands, if you haven't got enough tension on the wheel, you can actually hear it slipping on the top of the main wheel up here. So you just need to tighten it up a little bit that way. On some of your wheels, like the Ashford Traditionals, when you change from one wall to the next, you may also have to move this whole flyer, and it's usually on a sliding plate, so you can either slide it this way or that way, so that the drive band, as it comes over the main wheel, lines up with the groove in the flyer. If it doesn't line up, it will throw the drive band off. So as I say, if you're swapping it between two different ratios, you may need to adjust it, so that if you look at the back of the wheel or at the back of the flyer and actually get a sight line through, see that the whole thing is lined up properly. So if your drive band keeps falling off, that's usually the reason why.